Yes, we are live now, ma'am.
Okay.
Ma'am, you are not audible.
Now, am I audible?
Yes, ma'am. Yes, ma'am.
Okay. Good afternoon to all present here on the virtual dais. I, Professor Priyanka Deshmukh, on behalf of MCT's Rajiv Gandhi Institute of Technology and Department of Mechanical Engineering, welcome you all for the 4-day second session of Phase 2 of AICT AQIS sponsored online 1-week short-term training program on recent trends in energy management and audit. Topic for this session is recent trends in energy management and audit in building segment. It is my privilege to introduce our today's resource person, Mr. S. Ashok. He has completed his BSc BTech in Instrument Technology from Madras University. He is a BEE empaneled accredited energy auditor from Coimbatore. Now he is empaneled by BEE Bureau of Energy Efficiency, uh, the Ministry of Power, Government of India. He is the Vice President of IAEMP, that is the Indian Association of Energy Management Professionals. He has conducted energy audits in around 400 industries in India and abroad, and has over 40 years of field experience in industry maintenance, projects, commissioning, etc. I welcome you wholeheartedly, sir, and request you to share your knowledge with us. Sir, over to you.
Thank you, ma'am. Thank you, ma'am. Thank you so much. First, I will share my screen and then I will start my session.
Sure, sir. Sure.
Good afternoon to one and all. Namaste to one and all. I think it's the afternoon session. I think we will have more of energy. Already we have more of energy by our lunch and brunch. And we will have more of energy conservation, especially in the building segment. That's what I am going to discuss now. Thanks for giving this opportunity to MCT's Rajiv Gandhi Institute of Technology, Mumbai, because this energy conservation is an area where every industry, every building, either the old building or the new building or a residential building or a commercial building, all the buildings have not concentrated till now. So this is the area where, from the college angle or from the college students angle, this is an area, nascent area we can say, where we can venture in and you can see lot more is going to happen in the energy segment, especially on the building side. This is what we are going to concentrate here in this session. I will be more happy to receive your questions, interactive questions. I will be more happy. Let us go ahead, please. To start with, see the building segment. One second, I am just getting one more. This one, I don't know why this is coming. Is it clear to you? Your my PPT is clear to you?
So just that window is appearing. Now it's not. Okay, now it's clear, sir.
Okay. The buildings consume almost 30 to 35% of the electricity consumption in India. Next to the industry, industry is consuming around 45 to 50%, somewhere around 55% also. Then comes the agriculture, then comes the buildings. See, why we are concentrating in the buildings is, see, by knowingly or unknowingly, we are losing lot of energy in our existing buildings. This is what we want to tap here. The global construction industry is growing at the rate of 5% per annum, whereas Indian construction industry right now, because why this is the hot topic. See, you can see in the year, this year, especially last month, Bureau of Energy Efficiency has taken a step. We will have an energy auditor meant for building segment alone, apart from the industries. So this is where each and every industry or each and every building will have to be audited like a typical company. The like a finance audit, the energy audit also has to be there for each and every building to know the energy performance indicator of the given building. That will show the health of the building, sustainability of the building, whether it is as per the ECBC, Energy Conservation Building Code, that has been there since 2017, and all the buildings we are seeing whether it is pertaining to the energy ECBC code now. And then comes this till another 10 years, two-thirds of the buildings are going to be built where we want to see the energy efficient technologies that are all inbuilt in the building. The BMS or the building management services or the building management system and the BEMS, building energy management system, they get automatically get into it, and BEMS will be a part of that BMS, and totally we will have a control on all the building management energy consumption as well as water as well as the green building part of it. So of the buildings, we see the commercial buildings. They are the third largest consumer after the industry and agriculture. We are not restricting ourselves to total commercial buildings. It can be a commercial building, it can be a hospital, or it can be a hotel, it can be a five-star hotel, or it can be any hospitality segment, or all the public utility buildings, where the number of people are more and their consumption is more by way of building energy consumption. This is what we want to look into. Going in depth, where we stand on the commercial buildings, the energy saving potential is around 25 to 35%. Whereas on the existing buildings, it is around 10 to 15%. But on all the residential buildings, we can achieve 20% savings. This is what we want to see now. And the action plan is getting accelerated now because of the 3-year plan meant for the ECBC, Energy Conservation Building Code. All these energy audits are done once in 3 years for all the buildings, for all the industries, to ascertain the efficiency of the building. Let us come into the case study where the government has done it, the institutions has done it, and what is done in the case studies, and what we derive from the case studies. If you see the NITI Aayog, it is a premier policy think tank of the government of India, both in directional as well as in policy inputs. This is what we are concentrating here. This is concentrating both in the direction of the government to take, the think tank has to take what direction, and as well as on the policy inputs. So first they have done this through Energy Efficiency Services Limited. They said that they have occupied a huge premises. They said first, instead of telling others, telling the industries or the buildings to do it, let us do it in our office, in NITI Aayog buildings. Total premises it is done, and they analyzed and totally identified the target areas. Bureau of Energy Efficiency says only one thing: let us target the energy consumption and the losses, then only we can reduce it. This is our targeting to consumption, energy consumption. So here we find the interventions that are monitored by the EESL and the physical verification was carried. It's an actual case study, and this is a typical case study which has to be applied on each and every building. Say in your college also, in any of the college institutions, or any of the professional and academic institutions, and all the institutions will have the buildings or multiples of buildings where this can be applied upon. Say, to take this existing building to an energy efficient building, what all it is done? The NITI Aayog building is done like this almost some 5 years back. You will find the 5-star rating what the government has promoted, more the stars, more the savings. This is what we wanted to achieve in the given buildings. And the existing gadgets which are all consuming more of energy, it has all been replaced with the energy efficient gadgets, and we will see ultimately what is the macro energy consumption of the given building with the new gadgets and appliances. See, LED lighting, almost you can see almost 3000 of LED lighting has been done. Almost 50% of savings is possible from an ordinary existing fluorescent tube light. Then comes the star air conditioners, B star rated air conditioners. This is changing every year. The star rating is changing every year. There you find the which was the AC, which was consuming almost 2 units per ton. Now it is consuming around 0.5 to 0.7 units per ton thanks to the inverter concepts and the energy efficient concepts in the compressor and the fan, especially in an air conditioner. They have improved their this one, and they have reduced their consumption from 2 units per ton to almost it is less than 1 unit per ton. Then comes the energy saver for the ACs. Normally, the energy consideration of any given building or a system or a process, we say, what can be done on the existing system to improve upon it? What can be done on an existing process? This energy saver is a concept. It's a, see, in the energy conservation, it is like that. It is like that you are in the core team of mechanical engineering, but still, mechanical engineering people, the students as well as the faculties, they have to know what are the electrical inputs that is taken by the mechanical equipments. See, the energy input for a given equipment that decides the health of the equipment or the performance of the equipment or the productivity of the equipment. This is where we are concentrating. And for a given air conditioner, almost this energy saver concept, which is a EEPROM based microcontroller that has been applied to all the air conditioners, not the split air conditioners and all the package turners. And this is able to reduce the consumption by 25 to 30% for the given premises. Then comes the energy efficient chillers. We had all the reciprocating compressors long back, decades back. Now we have gone for scroll compressors, we have gone for screw compressors, which is able to deliver almost points of units only it consumes for a given tonnage. Compared to the old, say we had some 200 tonner or 300 tonner machines in all the hotels and hospitals, that is consuming less than 50% now, especially in the energy efficient chillers. So this EESL, this case study, coming to this case study, EESL they have done is, let us take all the electrical distribution, energy efficient products like water pumps. Say a motor when it is replaced, it gives around 5% or 10% savings. But a pump is replaced or a blower is replaced, it gives almost 30 to 40% savings. This is what I am going to discuss in depth, where as a core mechanical engineer, what you can see, what you can deliver to the your premises, to the industry or to the nation is the energy conservation based on your inputs from the mechanical side. Any process or equipment, electrically say 10 to 20% only it is consuming, that is the input, prime mover up to the motor. But almost the load side, that is consuming more than 2/3, or you can say 75% is the consumption is by the load only. So what all the energy conservation is possible in a given system is you do the optimization in the load to match to the productivity and reduce your energy inputs. So energy efficient pumps, then comes the solar SPVs, rooftop solars and other aspects. Now all the college institutions throughout the India, on many states, they have gone for it, the standalone rooftop solars, and they also have windmills and existing windmills. They are already having a tie-up, and this automatic power factor control to maintain the electrical distribution. So in this case of this Niti Aayog study, they are almost paying almost say 2.7 crores they invested on this energy efficient investments, especially on all the star rated equipments, on all the energy efficient products to be retrofitted in their existing buildings, and they are able to get almost 1 crore as the yearly return. This is not possible anywhere in the industry. You go to any bank or you go to any finance institution, whatever amount as a student, if you are putting 10,000 rupees, or if your parent is putting 10,000 rupees for 1 year, he will hardly get say 500 rupees or 1,000 rupees per year as the return, the maximum return on investment. Whereas the return on investment on the energy conservation is around 30 to 40%. This is what we wanted to capitalize. We are emphasizing only this point now. We have to capitalize, and this is a area, nascent area, virgin area, and it's a gray area where the industries or the buildings have not concentrated. Let us concentrate. Even wherever we, as a part of energy, Indian Association of Energy Management Professionals, we are having a lot of student chapters throughout the India, in many of the states. We all tell the students, concentrate on the energy conservation. That will be your part of your curriculum, and this energy audit and conservation will definitely take you better to the any industry, because all the industries, they don't want engineers now, they want energy managers. An engineer, yeah, from mechanical or electrical or civil or anybody, he can be called as an engineer once he enters the industry. But once he is certifying himself as an energy manager, your position in the organization is automatically propelled up. It is taken more, and he is given an excellent the position, designation, name, and the fame, apart from the salary hike. This is what we want the students to especially make use of it. So if you find for 2.7 crores of investment on this Niti Aayog buildings, 1 crore was the return per year, almost 40%. And almost 24 lakh units was consumption before, almost 12 lakh units is the consumption after, almost 50% of the consumption is saved. Then comes the, see, for again, energy and environment, it's all part and parcel. Where when you are able to reduce 1 unit of electricity, you are able to reduce the carbon dioxide liberation by almost 0.82 kg, to be specific. So I am able to save almost, say, 12 lakh units, means I am able to save almost 1,000 tons of carbon dioxide reduction. This is a part of clean development mechanism, and this is what carbon emission reduction, this one CERC, that is what each and every industry is looking for it. And each and every industry, when you say our Rajiv Gandhi College is going for NAC accreditation, this green building has to be a part, and the energy consumption of the EPI, energy performance indicator, for your given building has to be in norms, in par. This is the hard cake or the hard point which is even discussed by all the government sectors now, starting from the Prime Minister's office. Especially the norms, especially the making the net zero energy consumption building, NEZ. That is what everyone is looking for, net zero energy consumption. The 5-star ratings to the students, if I say specifically, we can learn a lot once you are able to study the nameplate of a given pump, given motor, given air conditioner, given water heater, given fridge. Everything gives lot of inputs to you. What is an energy input and what is the deliverable? What is the input and output, and where you are having a obstruction in the process in the form of hotspots, that is going to be a energy loss, that will reduce the output or it will increase the input. Ultimately the equation is same. Output by input is efficiency. If you want to maintain the system's efficiency, we can have in such a way that we can definitely reduce the energy consumption for the same given output. This is what the energy conservation, we look into it in the process in the industry. Now this is not even done in all the domestic side, it is being taken to the industries also. We talk about transformers, which is the heart of the any industry. It takes from almost 11 kV high voltage, extra high voltage, and they are giving 450 volt to the industry. There also all the IS 1180, this standards has been applied to all the transformers, then all the motors, then all the pumps, blowers, compressors, everywhere. The 5-star rating or the energy efficiency ratings has been applied by the government and the government monitored agencies. They are doing in a big way. The air conditioners is a very big field where year by year, the yesterday I had a, that is last year I had a 5-star AC, but this year that same 5-star AC is became a 4-star, because the energy EER, energy efficiency ratio for a given air conditioner, it is increasing now. The efficiency of the AC is increasing year by year, and thanks to the inverter technology, we are able to consume at a very less. Now many of the air conditioners are run by solar, thanks to the BLDC motors, brushless DC motors, and the inverter technology, which makes the system with the least consumption, energy consumption, and deliver the same output. So the energy efficiency devices, every year it can deliver almost 1.2 lakh crores of rupees. The ASSOCHAM is, the statement of ASSOCHAM is that. So 20,000 megawatt of power is savable, and almost 1.2 lakh crores of this. See, these are all part of National Mission for Enhanced Energy Efficiency. That is the government's mission, National Mission for Enhanced Energy Efficiency, and the government is pumping almost 75,000 crores in the year 2014 to 19, and it is extended also. 74,000 crores is what is targeted to be used to improve the energy efficiency of a given system. Maybe it's a equipment or a process or an industry or a society or on the automobile segment, whatever segment you take, or the agriculture. Coming to the 5-star rating, see, I'm just talking, see, the energy conservation and the, as a topic, it has a variety of usage applications. It is having applied in industry, it is applied in agriculture, it is applied in the domestic side, and it is applied in industries also on the energy efficiency and on the renewable side. Now coming to the building segment, that is what I am just focusing now here. The 5-star rating for a given fan, ceiling fan. See, the World Bank has given $300 million to India to improve the performance of the existing fans from ordinary this FHP coils. They have gone for brushless DC fans, which is consuming only 30 watts and is delivering. A company from Mumbai or say Maharashtra or a company from Coimbatore, Superfan or Attenberg, they are all giving almost, they consume only 30 watts in their fans, and they deliver almost 230 meter cube per minute. See, the service value of a given fan, as the service value of a fan, and what does it deliver? Normally, it is the 5-star rating is stated like in such a way that a typical, some 5 years back, these Havells fans and all came. That is the 50 watts, ES50 they say. 50 watts will be the fan input wattage, and it will deliver more than 200 meter cube per minute. That is the flow for a given static pressure. This is having a service value of 4, and service value of 4 and above is rated as 5-star. See, the star rating for a given appliance, if you go into the star rating, you can learn more about the efficiency of the appliance. Each and every nameplate of a tube light or a pump or a fan or a compressor or a fridge or an air conditioner. This gives lot of inputs to you. You can take it, see, in our student chapters of our IMP, we are asking the students to do the statistics through our HERM, Home Energy Resource Management. We ask them to start from their home. Charity begins at home, conservation begins at home. A student who is always on the conservation, is having an attitude towards conservation, towards material and energy conservation in home, he will shine better in the industry. This is what our Dr. beloved Abdul Kalam, APJ Abdul Kalam, our beloved past president, he used to tell us. He, in fact, he is our college senior. He used to give lot of inputs. The T&D loss has to be addressed first. Whatever that is delivered by the coal and thermal stations, we are running coal. See, throughout the world, India is using lot of coal-based thermal stations. That is the base of the energy generation. Now renewable, solar renewable, now it is costing less than 2 rupees per unit. It is coming up, but it has to come up in a very big way. Solar wind, solar mills, solar SPV, solar power generation, and this windmills, all the aspects are renewable have to come, and they have to camouflage. They have to superimpose on the existing base generation of coal-fired thermal stations, and we have to live with all the hybrid variety. India is a place where it is a heterogeneous place where all types of people or all types of segment are there. Like that, we need all types of energy. We need energy from biomass, especially for all our boilers to run the firewood with the firewoods. We need the nuclear energy. We need coal. We need all the LPG and coal, diesel, petrol, everything. A country like France, they are having 80% energy generation done by nuclear. But in India, at least whatever we are trying to generate, let us try to generate more efficiently. We are at an efficiency of only 35%. We wanted to increase the efficiency of generation from 35% to almost by 40-45% by the ultra critical thermal plants, and we wanted to swap and replace the existing wetted parts in the thermal plant to make it more energy efficient. Now coming back to the ceiling fans, a ceiling fan is rated 5-star if it is having a service value for a given 50-watt input, electrical input. It is delivering to 200 meter cube per minute and above. A 30-watt, a BLDC fan like an Autumnberg or a super fan, They deliver for a 30-watt input, they deliver more than 230, 250 meter cube per minute. It is a 7-star plus. This is how the trend is going now. The stars are growing more the stars, more the savings. This is what we wanted to achieve here. You can see the existing fans, all our decade-old fans, which was consuming 60 to 80 watts. See, as a mechanical engineer, don't limit yourself to mechanical part only. You have to know all the branches of industry, engineering, when you come to energy audit and conservation. An energy auditor is a person, he is a jack of all trades, including myself, I am telling you. We have to be a jack of all trades, but mastering none. But still, we have to know the mechanical part of it, hydraulic part of it, electromechanical part of it, electro-pneumatic part of it, all the pneumatics, computer-based peripherals and accessories as a system, and on the see, all the things we have to learn. See, a typical Indian is always a jack of all trades. That you keep it in mind. And you don't restrict yourself that you are a mechanical engineer, I am a core mechanical engineer, I will not even have an eye on the electrical side. Then you cannot enter the energy conservation segment at all. You have to know what you are doing, and you keep your eyes and ears open to all the other branches of engineering, because you have chapters about electrical and other aspects. So let us get into all the aspects of engineering to have a total energy efficiency equipment or a system or a process. You will find on this one, on the especially on the mid portion, yeah, ordinary fan consumes 45 watts, whereas a BLDC fan consumes only 11 watts. Almost 25% is the consumption, and it is able to deliver the same output. This is what we are concentrating on, our energy efficiency. Now, I am coming to another case study. It is done in a typical institution like an IIT Kharagpur, where what the energy conservation on the energy efficiency improvements is done on the given building. Say, the energy conservation or the efficiency improvements can be done in different ways. One is building envelope optimization. I will go in depth into that in the coming slides. Then the lighting optimization, then the HVAC optimization, then the controls. Controls, you find I'll just come to it. The controls are the practices. The energy efficient practices are the culture, the people culture. Yeah, rational thinking is when I am not in the room, you are sure to switch off the light or fan. Like that, the culture of energy conservation practices has to be inbuilt for any person in the family and in the college and in the industry. See, if you see the energy ECDC compliance done on an educational building like yours, envelope optimization gave almost 15% savings. Lighting optimization, it gave 20% savings. HVAC optimization gave 20% savings. And controls, 25%. So, the possibility of savings is huge in all the aspects on the energy generation, energy distribution, and energy usage. We will go by the annualized energy losses on the existing equipments. I will go into it as it. So on the building envelope side, we say the building exterior facade, where the building is the orientation of the building is with respect to the north, south, east, west of the directions. Then the walls and the windows and the roofs and skylights and doors and openings. All the windows are provided with double glazed or triple glazed glass tiles, so that the solar heat ingress is happening only in the top of the building. And that too, now many of the high-rise buildings, they have gone for this SPV, solar power plants, captive power plants, 5 or 10 kilowatts or 15 kilowatts or 100 kilowatts, depending on the size of the building. And for every 1 unit of 1 kilowatt of solar plant, we are getting almost 5 units. A typical of any Indian setup, it gives almost, we are getting 5 units per day for a 1 kilowatt of solar. So let us make use of the solar, this one, especially in the top. See, the heat that is getting ingressed from the solar insulation on a given building, 50% is more only through the open terrace from the top only. On the sides like north and south or east or west, it is less only, but that also is prevented or avoided by going for glazed tiles, like glazed tiles and these double glazed and triple glazed windows, glass windows. Then comes the mechanical systems, where we go for the HVAC, heating, ventilation, and air conditioning. Heating is not there as India is concerned. We call it as refrigeration and air conditioning. Refrigeration we are using it for our equipments, and air conditioning we are using it for our premises. Okay. Then comes the interior and exterior lighting. We have gone for all from mercury vapor lamps, sodium vapor lamps, everything now it is boiling down to LED lamps, and it is going to sustain. And now we are going for organic LED, OC LED, lot of other future improvements, research, and everything is going on, and it is being tried in many of the developed countries, and it is coming to India as well. And on the electrical systems, what are all the possible things on the transformers, on the motors, on the renewable energy systems, on the automatic power factor control systems, all the distribution losses, it is corrected in the electrical system. Here, especially when we talk about the heat that is getting ingressed into the building, the solar radiation. We see the solar radiation in terms of, see, you may think I am above 60, but still I am revisiting to the basics of engineering now, especially in my each and every audit is a lesson to us. We learn on each and every audit. We learn more of the basics, and we are revisiting to the basics to get more juice in the existing system and make the existing system more efficient by revisiting to the basics. Why I am suggesting this is solar radiation, three types of radiation: conduction, convection, and radiation. This radiation emitted thermal radiation is around 0.75. All this convection and the incidental sunlight, how this can be attenuated, how this can be reduced, or how this can be mitigated. It can be done by heat reflective paints, or we have the thermal insulating tiles on the existing buildings. See, many of the buildings having done you can see the right side figure, the conventional roof absorbs almost up to 80 degrees of temperature when you see by a thermal imager or a thermal camera. On a heat reflective paint, once it is done, albedo type of painting, now many of the painting measures have come. And once it is painted on all our buildings, especially on the rooftops, you can see the indoor temperature is instead of 34 degrees, it is at 27 degrees. On the cool roof, the temperature of the roof gets cooled from 80 to 50 degrees because of the radiation that is achieved by the heat reflective painting. It's basically a polyacrylic chemical that is embedded into the painting compound, and it is being smeared in all the rooftops. So the performance of the rooftops is again based on the SRI, solar refractive index. See, some of the technical jargons, as a mechanical engineer, you can learn more, because when you want to survive in the industry, energy conservation is the only area which is open to all. See, this is an area which is like that, it's not focused or narrow ending. It has an open area. I'll just come to at the end of my session, I'll say where are the areas which is open to all the mechanical engineers, where we can pounce on the positions, vacant positions, if we are energy conscious. So for the energy consumption for a given building, energy consumption is not only depending on the type of the building or the orientation of the building or how it is constructed, but also the interiors of the building, like the lighting arrangements, lighting accessories, lighting system of air conditioning, and how the air conditioning system is ducted inside the building. Distribution losses are more in the given systems, existing buildings. That is what we want to look into it. In many of the cases, the payback, say, I just told you the initially, you are investing 10,000 rupees for your family in a bank, you get only 500 rupees or 1,000 rupees, but you are able to get 4,000 rupees when you are investing in energy conservation. You keep this analogy in mind. You keep this business mathematics in your mind, and you plunge into the this energy conservation part of it. In fact, I have replaced my fridge, which is consuming 3 units per day, some 10 years back. Now my existing new fridge is consuming only 1 unit per day. 70% of energy savings is achieved by the star ratings changing from low to high. From 2-star to 5-star ratings, I am able to achieve almost 70% of energy savings achievable in a fridge. When it is achievable in a fridge of a 200-liter fridge, it is very much achievable on a 2,000 square foot building also in the HVAC segment. Now coming to I have just talked about the case studies. educational case study and the office case study. Now coming to the energy conservation trends, what is applied in the given building, let us discuss in depth. See, for a given building, we see the energy breakup. Almost 60% goes to the HVAC, air conditioning. But post-COVID times, people or the residents or the occupants are advised not to use their AC at a chill temperature at 20 or 22 degrees. Post-COVID times, we are bothered about the indoor air quality. See, HVAC is a leaf out of your mechanical subject, but HVAC is an area that is going to grow in a very big way, especially in India, where it is a tropicalized climate. The air conditioners are exploding in the market, but the same can be definitely controlled and operated optimally. The government recently, an year back, brought a gazette notification. Operate all your air conditioner settings from 16 degrees to 24 degrees. Raise your settings to 24 degrees. Why it is done and what is the impact on this to each and every individual? Let us go into it. One is the HVAC, other one is the lighting, other one is the lift, then all the pumps and other blowers and other things. On the HVAC, we deploy the three-tier systems. One is heat avoidance, how to avoid the heat, especially on the roof or open terrace of the building. If we some buildings, if you find some of the telecom buildings or the railway buildings or some of the public sector buildings who have thought way ahead, they have kept their genset on top of the open terrace. They have kept all their solar rooftops on all their open terrace. And they have put a pakka shade on the open terrace so that the heat ingress they are able to avoid almost 30 to 40%. Then comes the passive cooling, as I was telling about the glazed tiling and the windows, double glazed and triple glazed windows. Then comes the mechanical. See, first any type of building that has to go by the three types of three-tier approach. First is the heat avoidance. After doing that only, then you have to go for the passive cooling, and after that only, then you can analyze and find the heat load calculations for the given building. What is going to be the heat load calculations? What is the how much of tonnage of AC is required for the given building? See, India is a typical country where air conditioner, how much it is needed, why it is needed, in how much, what is the percentage it has to be put to use. You will be surprised. The research have all come to your place in Dharavi, and many of the huts had an air conditioner along with a ceiling fan. An air conditioner and a ceiling fan, that is, you are increasing the air circulation than the air conditioning. By that, you are able to reduce the energy consumption. And many of the places, especially in Mumbai, they have gone for this air circulation and air conditioning only. And Mumbai is the place to start with, and it has been deployed in all the other cities. And the government also is suggesting now, wherever you have the premises like cabin or a service this one or a service premises or a building, try to have the air circulation. You can see the what is the energy consumption for a given air circulation. If you first see on the first second slot, yeah, ceiling fan consumes only 10 watts per meter squared. If you see an air cooler at a place like typical like Nagpur or a place where the RH is so low, the human comfort wants around 25 degrees centigrade as a temperature and a RH of around 55 to 60. That you keep it in mind. This is a thumb rule. See, when you go to the industry, we learn a lot of thumb rules. What has to be applied to the given industry? A typical human comfort calls for 25 degrees is the ambient temperature around the body, and around 55 to 60 is the RH, that is a comfortable relative humidity levels. So the energy demand, if the relative humidity of the given place, like say Nagpur or any interior place in India, it is almost very dry. There you need almost 4 times, 40 watts per meter squared. It is 4 times the air circulation. But if the same place is done an air conditioning, that has to be 20 times. That is why let us decide or let us go by plan. First to have the air circulation, and if your place is already humidity is okay, normal above 50 or 60, then you go for air conditioning. If the place is less than 20 or 30, then you can think of air cooler, evaporative air coolers we call, which is making use of the ambient bed bulb temperature. This is what making use of the ambience around an equipment or a process. This is what the industry is trying to do to improve their efficiency. See, throughout the world, Indians are rated for their peak hour productivity, not for 1 or 2 hours of a day. They are rated for more than 8 to 12 hours of a day, because the ambient temperature in India average, it's around 30, 35, like that. And our body temperature is around 37. When the human body temperature and the ambient surrounding temperature is on par, is almost near to it, our productivity or our intellectual and the physical productivity will be much more. You have an equipment or a process in a place like Finland or Scotland or Sweden or Norway, or the same equipment which is working in India, in Mumbai or in Nagpur or in Chennai, the efficiency matters a lot depending on the ambient surroundings. This is what a mechanical engineer is supposed to do a research. See, energy conservation and audit is a tip of the iceberg. You have to explore more to find a lot of energy losses that is happening in the system. And we are, as an energy auditor, I have done around more than 400 energy audits. But I learned a more when you are doing the system-wise energy audit or a process-wise energy audit instead of an equipment energy audit. So, what is the deliverable required for a system, and what is the input the system takes? As I was telling, the peak hour productivity is much more in India, because of the climatic conditions also is facilitating us to work suitably, efficiently more. We all need around 25 to 27 degrees as our air conditioner setting. The government has taken the step in the right direction. Change all your remote set points, all your split ACs from 16 to, you set it to 24 degrees. All the OEMs have come with 24 degrees minimum now. You cannot reduce your AC settings to less than 20 or 16. This is what is wanted. See, self-discipline is the first and foremost in energy conservation at home, in the college and in the industry. Then comes the reduction of heat ingress, especially in the terrace, and then the AC improves by itself. Especially the AC outdoors, when it is kept in the open terrace, if it is provided with the weather shade, their run hours, instead of 10 hours, it will run for only 9 hours. You are able to run the AC efficiently, because it has to evacuate the heat from inside the premises, but it cannot be boiling under the sun. So you provide a weather shade to improve upon the existing system. How to reduce the AC settings and what is the savings that is possible? A simple mathematic to say, if the ambient temperature is around 25 or let us say 35, and almost you get around 20% savings. If the ambient temperature is more than going 45 and all, the savings is more by reducing the settings of air conditioners. A simple calculation to show, you are setting your AC at 20 degrees and you are raising the setting to 25 degrees. How much of savings is done? 20% savings is done. This is what is wanted by each and every individual who is an energy consuming individual. Coming to the building energy segment, AC segment, let us see the AC segment on your given building. It has all the inputs for a typical mechanical core team. It has a screw chiller, it has a variable speed drives or a secondary pumps, primary pumps, then variable speed blowers, air handling blowers, then all these fresh air blowers, then moisture sensors. See, you can see the percentage of savings on a given building. It is varying in generation, distribution, and the intelligent usage. If you find the motion sensors, everything is operated by infrared based automatic sensors. When you are not there, either manually you switch off or automatically this will switch off by itself. That incoming diffuser on the AC system and the lights and fans, that gives almost 15% savings. So the building automation systems, building energy management systems, it gives 10% savings. And I was just telling the energy savers, that gives around 20% savings. This is what is seen in the buildings. Now, any typical air conditioning, it is having three sets. One is the chiller circuit, the other one is the AC circuit, AC compressor, the other one is the air handling unit. Then comes the delivery, the diffusion inside the premises. Here, if we find, go by the Pareto principle, 20% of the power consumers for a given system, they dictate the terms for the 80% of the power consumption of the main compressor. If you say take your split AC, if your evaporator indoor air coil is getting totally choked, or the outdoor coil in your AC is totally getting choked or heavily dusted, automatically the compressor, instead of running for 8 hours, this will run for 12 hours. The peripherals or the auxiliaries or the subsidiaries, they decide the main compressor's hours of operation. How this can be done to reduce it as such? Say here for this, we are going back to the basics. Let us see what is the types of load we have in a given system. If it is an extruder or a mixer, let us say it is a sand mixer, or it is a, you can see the cement mixer on the roads. It is a typical constant speed type, and a pump or fan, it is a variable torque type. The load are defined three types of loads: variable torque loads, constant torque loads like a conveyor or a compressor on the reciprocating side, positive displacement compressors. They are all constant torque. Whereas a screw centrifugal compressor or a screw compressor are a variable torque. And these blowers and the centrifugal pumps and the centrifugal blowers, they are all variable torque machines, variable torque systems. You analyze the systems of constant torque, variable torque, and constant power, then you know how much of energy conservation is possible in each and every system. So, as far as an air conditioning is concerned, and the generation, how much can be saved on the zero cost and low cost, and on the distribution efficiency, how to improve the distribution efficiency by zero cost and low cost, and on the settings and usage, wherever it is not required, how to switch off the volume control dampers automatically, especially on the diffusers in the air conditioning ducts. A typical air conditioning compressor in your fridge you can take, or in your AC you can take in your house or in the college. It is supposed to be charged 100%. If the charging, the Freon charge, now the Freon, here also a lot of innovations are going on. GHCL or many other companies who are making R22. R22 is phased out totally because of global warming. Now R12, R22 is phased out. Now R32 has come, and R134A, R407A, R410A. Lot of refrigerants, latest energy efficiency and environment friendly refrigerants have come. It has been used now, and you will be surprised if you go back to your house and you see your fridge is charged with R600A refrigerant. This is a latest refrigerant which is compatible with R134A, where the Freon coefficient or the Freon input, Freon characteristics is in par with environmental friendly. See, we want the ocean depletion layered chemicals, ODC chemicals. These chemicals, which are all environmental friendly, we are taking into it. Which are all very much hazardous, we are replacing it now. You go to, in fact, I have done a lot of ISO 50001, these star rated buildings, where they strictly say, I am telling almost 10 years back, when I went to L&T or any of these platinum rated buildings, 10 years back itself, they have changed all their Freon systems to latest energy friendly, energy efficiency and environment friendly systems. A typical of your compressor AC, there is a fridge compressor or a AC compressor, if it is charged less or if the Freon charge has leaked out, automatically the efficiency drops by almost 70%. A compressor which is charged less, also it drops the efficiency by 30%, or a compressor which is charged more, that also it drops the efficiency by 30%, 25%. So this is where we always say, whenever you are charging your refrigerant, Freon charging for your given machine, always measure and charge, monitor to charge. Wherever it is possible, monitor to give the whatever the energy input you are giving to the system, monitor the system, measure the system, and then take the decisions. Then comes the high volume, low speed fans. This has been deployed in many of the industries and all the buildings. In fact, recently I went to Bangladesh for a World Bank project. On all the government units, they are using this type of 4 feet by 4 feet air coolers. This was giving so much of excellent air throw and at a very mild static pressure. You can get almost lakhs of CFM at less than 1 kilowatt of power, and the deliverables is more, and it is able to improve the human comfort, especially in the garment factories. Wherever the factories or the industries where the human employment is more, you see it that as you don't learn energy conservation alone. Human comfort or the personal protective equipment is more important for a given industry. Then comes the personal comfort. Then only comes the equipment safety and the equipment conditioning and the equipment optimization. So always have a value for human safety, and wherever you are in college or in the roads or in the society, give value for the human safety first. Then comes to the energy conservation. When safety is done, when safety is the undercover, automatically energy conservation can be achieved. This is what we want to do that. You go to any of the malls or any of the big buildings, even in churches, in temples, in all the halls, they have started fixing these HVLS, high volume, low speed fans. You will have your ceiling fans which is running at so fast, but these fans you can count the speed. It will be running at 50, for 10 rpm, 20 rpm, like that. It will be running at a very slow speed, but it will deliver more by the wind chill effect. You can see the heat displacement or the heat transfer when this HVLS fan. If now all the commercial malls have fitted this, they have bypassed or they have switched off many of their air conditioners, and they have started putting these HVLS fans. And especially during this COVID times, this type of fans is very much important, predominant now. This can deliver an excellent fresh air from the top, provided you have a fresh air incoming provisions are there in the building. Then you have a wind chill effect, and the you can find the comfort, human comfort is very much improved if you are going to sit under this fan. We have been educating all the industries wherever the workers are more to go for this type of fans. Don't look for energy conservation. First look for the human comfort or the workers' comfort, then go for the energy conservation. Let us come to the blowers. See, this is another area. You are reading this chapter by chapter, subject by subject. But we as energy auditors, we are seeing it as a total system. What is there in the system? A pump or a blower or a fan or a compressor. What is there and how this can be made energy efficient? If you find the total energy efficiency of a given blower system is only 40% only. We are talking about 70%, 80% we want to achieve as a nationally, and in all the industries they want to achieve 70%, 80%. How this is possible? That is the crux of the session now. A typical blower. See, this is a study we have taken in a blower. Can be on an air handling unit in a ducted AC plant, or it is on a blower on a boiler blower, ID fan or a FD fan. We call it as an induced draft or a forced draft fan, no? In the boilers. The ID fan and FD fan is meant to improve the combustion efficiency of a given boiler. How this is achieved? This is achieved by a closed loop cascaded control for a given system by trimming the oxygen level on the exhaust of the boiler, and the combustion efficiency is improved by the master slave cascade controller of ID fan and FD fan. They are monitored in such a way the air is induced and air is also forced out in and out of the combustion chamber to improve the efficiency. See, a fan's performance is very much important for any of the industry. You go to any Tom, Dick and Harry, any industry you go, A, B, C, all the industries you will find 20% they will have a lot of fans, either for equipment cooling or for process cooling or for man cooling. IT industry is famous for man cooling. They want only the for all the IT machines, all the servers, and for all the human comforts when they are all working in the machines for more than 10 years, 10 hours or 20 hours a day, they need to have a definite sustainable, comfortable temperature and RH for a human comfort. Okay, now the system efficiency is the multiplication of the efficiency of all the subsystems. Let us say this blower is having a system efficiency of 40%. You just multiply each and everything. See, motors efficiency, VFD efficiency, belt and bearing efficiency, and the fan efficiency from 98 to 80 to 92 to 58. Automatically, only 40% was delivered at the output. So, if we have to improve the system efficiency, you have to improve the efficiency of each subsystem. This is the crux of energy conservation and audit, what we do in the industry. So we have improved from 98 to 90 to 98 to 70, the impeller. And automatically from 40%, it has jumped to 60%. And the industry is happy with almost 20% energy efficiency improvement for a given blower. You take a typical case of either a cycle pump when you are pumping for your cycle, or a typical blower, 5 HP blower. What is delivered is 3.7 kilowatt, but a motor loss, the drive loss, and the fan loss, automatically the air power, what is the electrical power delivered is 3.7 kilowatt. What is the air power delivered at the output? It is only 2.2 kilowatt. Almost 60% of the input power only is used as output. 40% is gone. Almost 1.5 kilowatt. It is going as heat. When you are using your hand pump for your to pump your cycle to inflating the air tires, you find after a few strokes your hand becomes so hot, your pump becomes so hot. Whenever the air is compressed with less of suction, starved suction, automatically air gets heated up, and it is a point of the thermodynamics play a big role, especially in the process, especially in the thermal system. And as and when you are aware of the thermodynamics of the given system and the enthalpy, total enthalpy of the given system, then you can become an excellent energy audit. See, what are the types of blowers we have in the industries? A blower with a backward curve, we can see the diagrams, they explain as well as such. Bureau of Energy Efficiency, if at all the students or the faculties, if you have time, I will suggest you go visit the Bureau of Energy website. It gives tons of information, energy related information. It's a treasure hunt there. You'll have tons of treasure of energy conservation, materials, and case studies, and what all it is done in the industries, they are sharing it to you. See, it is a cakewalk for you. Already the case studies are there. You have to deploy the case study from one to one, because as a student, you have one fellow is having Pulsar, one fellow is having Yamaha. But both the Pulsar and Yamaha, they don't give the same KMPL. It is different because the driving practices differ, the vehicle's efficiency differs. Like that, each and every industry or each and every equipment in the industry is operating in its own efficiency. We are here to find in the energy efficiency of the given equipment to optimize it and to maximize it. So if you see the blowers, backward power blower, radial blower, forward cloud, and airfoil, you can see the percentage of efficiency 79, 69, 60, and 80. This airfoil type is the best suited for all the IHU, air handling units, especially in the HVAC segment. In your college, you go and visit your air conditioning installations and you check your fans. What is the type of fans? What is the impellers that has been used in your fans, especially in the air handling units? B states the range, the efficiency is not a single point efficiency, it's a band of efficiency. You can see the right hand curve. It is a umbrella, inverted, the umbrella type curve. For a given flow rate, what is the efficiency? You are getting a efficiency at a peak only. There you have to make your system to match to the efficiency. You have to design the system to get the best out of the blower for the given system. This is where a typical mechanical engineer, he can place himself in the design aspects for a given organization. In designing a fan, what is the required CFM and what is the required static pressure? This is the critical inputs to be decided when you are able to design the fan as such. The fans affinity loss, we are applying this to all the centrifugal fans, to some extent on the axial flow fans also. They may not follow exactly 100% one-to-one, but it is applicable to all the centrifugal variable torque loads like fans and pumps. Whatever the flow is there in the across the fan, the RPM of the motor or the fan, whatever 10% increase in RPM, 10% increase in the flow. Whereas a 10% reduction in RPM on this fan, automatically the static pressure, we call it as the static pressure or the back pressure, it is reducing by almost 20%. Whereas you are reducing the RPM by 10%, the power to the fan, it reduces by 27%. This is what the industry is capitalizing on this. You can do a lot of research activities on this, because the government is also thinking how to categorize the variable torque loads, constant torque loads. Variable torque loads have an immense potential, huge potential for energy savings. This is what we are concentrating here. So you can see almost at 80%, 20% reduction in fan RPM gives almost 50% is the only the power consumption of the given fan. Yeah, VFD or the motor can give only say 10 to 20%, whereas this impeller change, it can bring almost 30 to 40%. The energy efficient recent trends in the fans are, people are not going for the centrifugal type, backward curved, forward curved, all these things. From forward curve, they went for backward curved, backward flat, and then they went for backward curved. Now they are going for plug fans or the plenum fans, which is high volume, high diameter, and the volumes are more and the static pressure is less, but it is able to achieve the same system efficiency. It has been deployed in all the AC equipments now. You can check for yourselves. As I was telling before, during the star ratings for a given machine, this is a typical nameplate on an air handling unit. It's an air blower or an air washer or an air handling unit or any type of blower, you'll have this type of nameplate. Go to the nameplate and learn more from the nameplate. This shows the nameplate, it gives a CFM, it gives a static pressure in water column, it gives the motor RPM, it gives the blower RPM, and what is the motor power. Automatically, the brake horsepower also is given here. So automatically the blower efficiency is around 30 to 40% only as a system. The nameplate indicates the efficiency of the blower, and you have to calculate by yourselves. If the blower is giving us some steady output, and if the output is getting choked due to some filters, automatically you can see the curve on the given blower. A blower with the highest flow with less static, if the static pressure is altered due to the system design by the duct design, automatically the blower gets derated by, from 12,000 it came to almost from 14,000 it came to 12,000, because the static pressure got altered. So the fan efficiency and the performance is more important, especially what is delivered at the motor, what is delivered at the fan shed, what is delivered, what is the type of impeller, and the industry is buying fans as a commodity. They should not buy the fan like a commodity. They should buy the fan with all the technical specs that you as a, when you go for industrial visits, you go to the industry and you ask for the blower spec. You learn more about the blower. Blowers are going to give lot of energy savings to the given industry. Even on the blowers, the blower link, the motor to machine power transmission by the belts, this also matters more. Previously, many industries, they went for a strong belts. The motor may break or the blower may break, the belt will not break. But now they understood, they went for a carved belt, this one, and they are able to achieve energy savings. They are able to achieve the excellent, the slippage was also very much less, like a flat belt, and V belt is getting outdated now, obsolete now. These are all the machine to motor to machine, the belt losses that is happening in the industry. If at all, from the college we go to the industry, you need a RPM meter, measurement meter, to show the industry productivity, and you need a thermal imager. You can see a 2 HP motor, almost 50% of loss is happening between the motor and the machine. The RPM loss from the motor to machine. You can measure and show to the industry, because the industry is not aware. They are only production centric or productivity centric. You can educate the industry. See, this is one way of reverse educating the industry to know about the energy conservation. Thermal imager. See, in all our IAMP chapters, student chapters, we insist that each and every college should have a thermal imager. Infrared thermal imager, it was costing more than 5 lakhs, 6 lakhs. Now it is available for 50,000 to 1 lakh also. Let the college department, mechanical department, electrical department buy one and keep one with you to measure the energy losses. Law of energy conservation says only one input. Yeah, energy input is given to the system, and the energy output that is delivered out of the system from the output, if it is not taken out, then the hotspots come in between, and that result in energy losses. Hotspot is a system of energy loss, and once you measure the intensity of the hotspot, then you know how much of energy loss is happening in the system. This is a typical case in an industry. The motor is running at almost 40 degrees. The machine is running at 40 degrees, but the belt is running at 80 degrees. This is an energy audit we have done in the year 2012. We have been using this thermal imager for the past 10 years in all our energy audits. This thermal imager is a part and parcel of our energy audit kit, which delivers more. See, if a college wants to shine well in the energy audit system, today or this week on Imager, you can go to visit the industry. They will give you a warm welcome to you, because you are not going to test the industry. You are going to make a non-invasive type of measurement in the industry to see the temperature gradient for the given industry, to study where are the hotspots and tell them where is the losses happening and why it is happening. The root cause analysis you can do from the college for the given industry. A typical speed ratio. Normally, what we studied in school days is applied in college, and what we studied in college is applied in industry. Efficiency into velocity ratio is the mechanical advantage for a given mechanical system or a given system. EVR is equal to MA. Efficiency into velocity ratio is equal to mechanical advantage. This is what we are trying to achieve in the speed ratio of the pulleys. For a given pulley, we have, instead of an 8-inch pulley for a given motor, we have just replaced by a 6-inch pulley, 2-inch reduction in motor pulley. This gave an energy savings of almost 40% on the driven machine. It is a fan where only that much of output was needed by the fan. So we are able to reduce by just replacing the pulleys, and we are able to achieve this. This is it is a excellent case study which we have taken to all the AC majors, AC OEMs, to the industry, to the even to the government. Any industry which is running these variable torque loads like your air handling units or air washer, 30 to 40% is saving possible with a VFD and a resized speed ratio of pulley and machine, motor and machine. You can see the motor pulley and the machine pulley at 130 and 155, whereas the reverse it is done as 170 and 140. And I am operating the blower at 1215 RPM at 50 Hertz in the first stage before. In the after same at 1215 RPM at 35 Hertz, I am able to achieve this 30 to 40% saving. This you can do as a homework in your college, in your lab, and then you can do it in the industry. The industry wants this type of jugaad. See, Indians are famous for jugaad. Let us do a lot of jugaads in the industry, in the institution, and showcase to the industry how this can be. See, 40% savings within 3 months. As I was telling you, this industry put in only 11,000 rupees they invested. They got almost 30,000 rupees at the end of the year. It is a huge energy saving potential that is there in all the variable torque loads. You just go in deep, you do the deep diving. The education is there to deep dive to the industry, because the industry people are running from pillar to post only for the sake of production. But as an academic research people, you can do this research and show them anything which can be optimized, it can be run at 30 to 40% energy conservation is possible. What is the energy savings possible with respect to a discharge damper and with respect to a variable speed drive? This is the savings. Instead of a damper or a pipeline, valve or a restriction, a VFD gives 30 to 40% savings on a system. Indoor air quality, I am just mentioning you again and again, because post-COVID times it is very critical. The government of the world talks about the vaccine and this one, but the manual vaccine vaccine is available to us, always have the face mask in your face, always covering your nose. You can avoid 90% of the COVID, this one, reactions. In a single cabin, when I am yawning, after 10 feet distance, you will also yawn because it is a virus which can spread like this, like yawning, like corona also. A face mask is a primary barrier to contain and curb the COVID symptoms and the COVID spreading also. Everyone, each and everyone, see, vaccine is a next thing to happen maybe in a month or two. But already we are facing the problem means have the face mask on. Indoor air quality is more important. If it is in the open area, it is not a critical thing, but it is a crowded area means it is very critical. Face mask is a primary and definitely a mandatory barrier for each and every human. It has to be mandatorily be there on the face and mouth to avoid the COVID problems. Okay. Now almost 800,000 ppm. That is what the CFM person as the CO2 measurement is done in the premises. See, this is again, it is an excellent subject by itself. All the data centers, I heard 35,000 crores of rupees have been pumped in Maharashtra to generate data centers. 20,000 crores is pumped by Amazon in Hyderabad to generate, to install all the data centers. All these data centers, all these HVAC installations where indoor air quality is very much critical now post-COVID times. Let us see, it is a wake-up call to all the industry and to the institutions. Let us make use of it. You go to any of your ducted units, when the fresh air filters are choked like this, how much of fresh air will be there inside the premises? See to it that your air filters are very much clean and neat. If it is left like that, if it doesn't have a pre-filter, can be cleanable daily. But if this is left within for a few months, it is left like that, and there is no fresh air that is coming into the premises. That is why many people feel very much sick. It is called as a when you are there in a system with a sick this one, there is no fresh air is there in a cabin or a premises, automatically you become sick. You always have the fresh air that is to be available always like that. WHO standard says lighting and ventilation on a given premises is very much important to avoid type of cancer or this TB diseases for in the humans. Ventilation is very critical. Again, going back to basics, 50% RH on the premises in the atmosphere, it has 27 kg of water vapor per hour for every 1000 meter cube per minute at 30 degrees centigrade ambient. But if the same is at the Bombay, if it is around 80 degrees or 80 degrees, 80% RH, automatically the kg of water vapor per hour is almost 45. That is why we suffer from lungs infection because of too much of water intake in the lungs. See, lung is an area where air has to go in and go out. If water is more in the air and water intake, as I said, the relative humidity. So the say you may not think I am talking. You may think I am talking out of way or out of box. But if you want to survive for long, especially in the metro cities, pranayama or the swasya pairji, or we can say the breathing exercise, have to be done by each and every human daily to cope up with the existing damaged civic amenities that is there spread throughout the metro cities now. I'm sorry to say this. Okay, now coming back to our basics, you find that the filters, a dirty filter is delivering a less flow and a clean filter is delivering almost 20% more flow. This is a proven system. You have a water column gauge or a, see now the digitalization has come. This is digital gauges are available for 8,000 rupees. You measure your all across your filters, you know how much of delta P is dropping across your filters to know how much of air is getting stuck in between to reach you inside the premises. Then comes the green building. See, these are all the case studies. Now coming to the green building, how these thing is all overtaken by the green building: energy efficiency, water efficiency, better living conditions, eco-friendly, sustainable materials. We have done an energy audit somewhere some 6 years back. It's a platinum rated building, and it is the first rated by the Indian IGBC. It is the seventh in the Asia, platinum rated. It's a German building, German company, where you could see the total energy consumption reduced by 45%. This I am telling some 6 years back. After doing the energy audit, they reduced more also. So they achieved all the aspects, especially the LED lamps, organic LED lamps, then these HVA systems. Then 90% of the area was daylit. The daylighting was there inside the system. They have used only fly ash bricks when they are constructing their building, and efficient glass, triple glazed glass for all the heat attenuation or reduction. So green building is that it offers the most effective means to achieve a range of goals as per the ECBC code, and the ECBC code also is getting changed every year. You would have seen the Prime Minister's address last week on these green buildings. Definitely, we have to take steps to improve the existing college premises as a green building and rate our green building with respect to the best rated green building. What is done is on the fly ash bricks on the walls, on the envelope, glass is on the low E glass, low emissivity glass, and the appliances star rated buildings, star rated this one, and on the renewables, and ultimately for last and the least, the energy monitoring. You have the energy monitoring in terms of electricity or the LPG or water consumption. Wherever monitoring is done, better do this right now. Coming to the lighting, you can see the different types of light that is available. As a mechanical engineer, we don't need to know about the lighting concepts, but we need to know what is the lux level in the room, which is giving more lux, which is giving efficient lighting to us. Of all the lightings, you can see the LED lighting gives 100 lux, 100 lumens per watt. Then comes no. It is the first and the foremost. The solar gives almost 1,20,000 lumens per meter square. Wherever the windows are there, wherever the attic places are there, attic windows are there, make your windows totally open. Grab the solar light inside the premises. You can grab almost 500 to 600 lumens in a diffused daylight through solar ingress. Then comes the LED. LED lighting has become the order of the day now. A typical mechanical engineer, he can very much go into the daylighting, which is done with a reflective, total internal reflection with all the aluminum, this one, gadgets, grabbing the daylight from the roof and putting it inside the premises. You can see a white light which is there in the premises. The premises is so big, almost 600 square foot area, and this one daylight, this one's lighting, it is able to cover so total big area with the 200 lux was the level that is available. Daylighting is possible in all the commercial and all the buildings now. Coming to the pumps, our age-old pumps, they are operating at an efficiency of 30%. The new generation pumps are operating at an efficiency of 70%. I don't say pumps, it is a pump system. Pumps means motors, couplings, then the throttle valves, then the piping efficiency. You can see the difference in efficiency. The old piping efficiency was 70%, the new piping efficiency is 90%. So the piping efficiency has to be improved if you want to replace the pump. The government or the industry thinks by replacing the pump, I am achieving the energy savings. It is not there. You can achieve the energy savings when you are replacing the pump and the piping. Pumps changing from, see, the pump itself, you can able to increase by 10 to 20%, but the piping also gives a lot of energy savings of 20%. A typical 7.5 HP pump is replaced 5 HP pump by going for, instead of a GI pipe, it is gone for white PVC pipe. The energy savings as possible is almost 48%. You can try it in your college, in all your water pumps, and study the results, and then you just publish it. This is what we want. Showcase the energy conservation case studies from your college and then publish it in the papers. This is what the industry wants from you as it. See, the piping sizes also have been changed from 2.5 to 1 inch, 2 inch. They have made it as 3 inches pipes. And all the footwall, they have made as a 15% more footwall size to increase the suction. To maintain the NPSV, net positive suction head, to be maintained excellently. I was telling you before, 10,000 rupees it gave 500 rupees or 4,000 rupees. Pump manufacturer OEM from Coimbatore separate 3,500 pumps in Maharashtra, 1,000 rupees, and the return on investment, return rate of return is 7,200 rupees per year. Almost it is equal to 10,000 rupees means almost 3,600 rupees. 36% we are able to get on this energy conservation project. It is in crores, the project is done, and see to it that the system is made efficient. Leave alone, replacing the pump alone is not enough, but see, replacing the system. All the pipings also have to be checked. All the pipings have to be like this, like it's all called conjoined pipes. It cannot be sharp bends, it has to have a long bends, it has to be conjoined pipes. You can see water which is having a lot of surface tension and the TDS in the water content, 20% decrease from 4 inch. That is why the agriculture has already changed over from all these GI pipes to rigid PVC pipes. Only the industry has to change it. By changing all the GI pipes to MS ERW pipes, earth resistance welding ERW pipes, they can achieve almost 20% in their pumping system consumption, energy consumption. Leave alone the pumps and pipings and the fittings. The pipe fittings, instead of using a sharp elbows and sharp bends, if you go for conjoining bends in the airlines and in the pumps, see in the traffic you can see when you are driving your vehicle, you have to go slow into the bend and come out of the bend fastly. This is what is deployed here also. You are applying the verticalized principle. Where there is a Venturi contractor, VC, Vina contractor, see, you can say it is from your college to the city, around 40 feet road is there. 10 kilometers. At the 4th kilometer, this 40 feet road became a 20 feet road because of a culvert. You will know daily the traffic will be so jammed only at the 20 feet culvert only. So, wherever the energy movement or the process movement or the human movement is there, make the conductors bigger. Universally, make the conductors bigger and the rotators smaller. We are happy with Ambassador from 1970s. We are happy with this Maruti 800 in the 2000s. Like that. The rotating equipments have to become smaller. They have to consume less space and give more efficiency. Instead of 10 kmpl, 10 kilometers per liter, we are getting 25 kmpl now. The payload capacity matters for a given vehicle. That is what we are looking at it. So for a given pump, one is the NPSH and what is the optimum delivery pressure to be maintained. The optimum suction pressure and the optimum delivery pressure will decide the pump energy conservation in a big way. Measure your pumps in the college or in your house. What is the delivery pressure, what is the nameplate pressure and what is the delivery pressure that is happening in your pipe. When pumps energy conservation is done, definitely water also has to be done. Water you find, the government has already given a gazette since last year, last January. Any pipes, taps, which is consuming 10 liters per minute, you put the aerator, especially for cleaning applications in the college cleaning and canteen applications. This consumes only 3 LPM. Almost 70% of water is saved by retrofitting these taps. This costs only 100 rupees or 200 rupees, but the savings is 70%. Have we retrofitted these aerator taps, aerator retrofits in our college taps or in our house taps? Look into it. Then comes the heat pumps. These are all the latest recent trends in the building segment. In house, we are using a 25 liters water heater or a 35 liters water heater, and we are consuming 2 units per hour. If you are putting a heat pump is a concept. Instead of consuming 1 lakh rupees, this consumes only 20,000 rupees, only raising the temperature of water from 30 degrees to 70 degrees. It is a typical case study. This can be done in any of the buildings. Have you done in For the, you see, sometimes you may need hot water. I don't say it takes only 1/3 of the electricity consumption compared to a heater. You can see almost the existing capacity was 108 kilowatts, and after the heat pump is installed, it consumes only 28 kilowatts. Heat pumps transfer heat by circulating the substance. Refrigerant. See, refrigerant is very user friendly. Let us make use of the refrigerant as user friendly and environment friendly. It is not that I make the refrigerant which is making use of myself and leave the surrounding others to leave them to dark. We want to survive means the surrounding people around us, they also have to survive. A heat pump is a latest technology. It has been deployed in all the building segments in case of raising the temperature from 30 degrees to 50 degrees or 60 degrees. So ultimately, the energy performance indicator for a given building, you can take all the blocks in your college, you can study this, and where do we stand? Each block to each block to block comparison. What is the EPI of the proposed existing building? What is the EPI of the standard building? Where the comparison, where does it lead to? Where do we stand? The energy consumption category, leave alone the basement, leave alone the open areas. What is inside the building only is accounted for this category. So the building management system has to definitely have the building energy management system also. It complements the BEMS. This is what we want to make use in. So the priority is more towards the conservation than towards renewable or energy efficiency. When there is possible to conserve, definitely let us do the conservation first. Lot of resources are there. Practicing is the energy conservation is more important than renewables, solar PV, or energy efficiency gadgets, or IGBT, or all these latest mechanical or EV innovations. But there are a lot of things, energy loss areas, which is seeing existing. Let us try to correct that first. This is more important now. That is what our IAMP's mantra towards this energy conservation. For mechanical engineering students, it is not that once you have done your mechanical degree, when you are going to have this energy management as one more degree, or I don't say degree, it is a certification done by the Bureau of Energy Efficiency under the Ministry of Power. Then all the sectors, the above sectors like all the thermal, aluminum, cement, fertilizer, paper, all the sectors want energy managers, and only 20% of the sectors they got the energy managers. They want more energy managers now into the industry now. Yeah, mechanical engineer, 1,000 mechanical engineers may be there, but only 100 energy managers are there. So after the college studies, just to get an experience of 2 years in the industry to feel the pulse of the energy consumption for a given equipment or process in the industry, simultaneously write the exam, then you become an energy manager. There is an ample scope for you to fly in come up in flying colors in your life. The industry wants they don't want any core engineers. I don't say relatively they want a energy manager better than a core engineer, because he is able to run the existing system efficiently than a core engineer or a designer. The government is also aiming that way only. So the industry wants, in fact, I have come across many of the engineering industry interviews where we give the inputs. Ask the students where is their attitude towards energy conservation in their premises. Maybe it's a college or it's their home. This speaks by themselves. Your attitude towards energy conservation, how we can come up in life. The less you conserve, the more you can leave it for the further generations. This is what we aim for. Thanks for giving a patient hearing. I think I have taken the the adequate time. I am leaving the forum for open questions. If you have any open questions within the college or within the society or in the about the industry, any questions related to energy conservation, you can definitely ask me. I am willing to answer your queries. Thank you. Thank you all. Hello.
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 Hello. Hello, sir.
Hello. Yes, sir.
Only mails you have sent and those
Hello.
screenshots.
हाँ sir.
Yes, sir.
रत्ना मैम. Hello.
Hello.
हाँ बोला.
Sir, good afternoon, sir. With your permission,
Okay.
there is one question from Sujit Kumar. I would like to ask you. May I have your permission, sir?
Please, ma'am. Please go ahead, ma'am. Please go ahead.
Thank you, sir. What will be the role of ECBC for commercial buildings or residential buildings?
See, the commercial buildings are consuming more, but it can be definitely applied to residential building as well. But the percentage of reduction in energy consumption in a commercial building, once the ECBC code is applied, that residential building, it can be applied to gated community buildings, it can be applied to all your institution buildings. And everywhere the energy consumption is there, the percentage of savings is relative, and definitely it is there.
Thank you so much, sir. Thank you so much, sir. Now I will conclude the question answer session. Over to you, Bhustekar, sir.
Thank you, sir. Thank you, ma'am. Now I'm going to give vote of thanks. It is my privilege to propose the vote of thanks on this occasion. I, Professor Narendra Bhustekar, behalf of MCTRJT, Rajiv Gandhi Institute of Technology, Department of Mechanical Engineering, and on the behalf of Organizing Committee of AICTE, AQIS, sponsored online 1 week short-term program, training program on recent trends in energy management and audit. Extended a very heartily vote of thanks to Mr. S. Ashok for accepting our invitation as a resource person and spending his valuable time with us. Thank you, sir. He has given a good insight on today's topic, that is how we can save energy in our domestic use also, which is surely has enhanced our knowledge in the given field. I would wholeheartedly thanks to you, sir, again, sir.
Thank you, sir. Thank you so much. I will definitely
Okay,
share
thank you,
my
sir. Thank you, sir.
PowerPoints.
Okay. Yes, sir.
Thank you, sir. I will definitely share my PowerPoint. I will definitely share my PowerPoint presentation, at least for knowledge sharing purpose. In fact, I am coming up with a practical guide to energy conservation. I am going to publish a book also on this energy conservation guide. I will definitely share with you also. Thank you.
Okay, thank you, sir. We have our next session 10 a.m. tomorrow. Mr. Arun Aniruddha Aswa. I request all of the participants to join the session. Thank you, everyone. I request the technical team to end the session.